In this lecture, we are going to look at development and simulation environments that can be used with PICs. We shall begin with the micro C development environment. Micro C development environment allows micro C programs to be entered, compiled, and simulated. It also allows the X files that are produced from the compilation process to be downloaded into a PIC. The details on how it works can be learned from working with the environment. In this lecture, we're just going to give a kickstart on how to use the environment. The rest of the functionalities, you can learn them on your own. I therefore encourage you to work as much as you can with the environment so that you benefit as much as possible and hence be able to exploit micro C development environment to your benefit. If you don't have the micro C development environment installed on your computer, you will need to first download and install it. You can search for it from the internet. There are some sites where you can download the installation package. Make sure that you meet the necessary requirements so that the installation is successful. This is the window that first displays when you run the micro C development environment. In order for you to be able to work with the environment, you need to create a project. To create a project, you go to the file menu, select new, and then new project. A wizard that takes you through the process of creating a new project is going to run. This is the screen that first displays in the wizard. Select standard project and click next to get to the next screen. The next screen is used to enter information about the project. In the project name field, you enter the name of the project. In this case, we have put the name as Flasher. In the project folder field, you can browse so that you get to the folder or the location where you wish your project to be located. In the device name field, you select the device that you're going to work with. There are several devices in the PIC families, so you select the particular one that you want to use in the project. In the device clock field, you enter in the frequency that the selected device is working with. After that, you click next so that you get to the next screen. The next screen is used for adding files to the project. At the moment, we do not need to add any files, so you click Finish. Once project creation is completed, an editor used to enter micro C programs is automatically opened. You can then enter the desired program. In this case, we want to enter the Flasher program. Thus, the editor with the Flasher program edited in. Once a program has been entered, it can be compiled. To compile a program, you go to the Build menu and select Build. The compilation process will then run. If there are any errors, you will get messages. If the process was successful, you also get a message to that effect. Compilation produces a number of files. To view these files, you go to the File menu and select Open. A dialog box is going to display. Select all types of files so that you see the different files that are associated with the project. You can then pick the file that you want to view. In this case, let's open the list file on the dialog box written as flasher.lst. This is the list file for our project. Basically, a list file shows the contents of each program memory location and each data memory location. On the portion shown, we can see the micro C program, the corresponding microchip assembly language program, as well as the corresponding machine codes for each and every instruction. We also see the memory addresses in the program memory where each of the machine codes is stored. To download a PIC program into a PIC, you need to connect a programmer to the computer ports. The PIC is in turn connected to the programmer. To start the downloading process, you go to the build menu and select build plus program. The program is going to be downloaded into the PIC. After downloading is completed, you can test run the PIC so as to check whether the PIC runs as per desire. Micro C has a number of built-in routines. When needed, these routines can be inserted as function calls in a program. Built-in routines make programming to be a lot easier and faster. Instead of redesigning some commonly used routines, the programmer simply calls these routines as functions and at desired points in a program. Examples of built-in routines are the delay routines. We have the delay microsecond routine and the delay millisecond routine. The argument passed to the delay microsecond routine gives the delay in microseconds that will be realized from the routine. The argument passed to the delay millisecond routine gives the delay in milliseconds that will be realized from the routine. As exercise, redo the flasher program using built-in delay routines. Let's now go into the Proteus simulation environment. The Proteus simulation environment allows PIC simulation circuits to be entered and their functionality to be simulated. Simulating a circuit enables the function to be checked before the program is downloaded into the actual PIC. Details on how the environment works can be learned from continuously working with the environment. Therefore, and again, I encourage you to work as much as you can possibly can with the environment so that you learn as much as possible and hence be able to get most out of this exercise. If you don't have the Proteus simulation environment on a computer, you need to search for the installation package on internet, download it, and install on your machine. Again, make sure that you meet the requirements so that the installation is successful. This is the window that displays when you run Proteus. Just like in Micro C, in order for you to be able to use Proteus, you need to create a project. To create a new project, you go to the File menu and select New Project. Alternatively, you can click on the New Project link on the window. Once you do this, a wizard that takes you through the process of creating a project is going to run. This is the first screen that displays during the wizard. In the name field, enter the name of the project. In this case, we've entered the name as Flasher. In the path field, you can browse to the folder and hence location where you want your project to be located. After that, you click next so that you go to the next screen. In the next screen, you can select create a schematic from the selected template. Then after that, you click next. You get to another screen. In this screen, you can select whether you want to create a PCB layout or not. For now, select do not create a PCB layout and click next to get to the next screen. In the next screen, select create a firmware project. When you're using a PIC, you're going to end a program into the PIC, so it is a firmware project. Hence the selection that we made. In the family field, you select PIC 16. In the controller field, select PIC 16F877. In the compiler field, it's selected, but that's the default that comes in. So you can just leave it as the default compiler. After that, you click next to get to the next window. The next window is a summary of information about the project that we have created. Click finish. After the project has been created, the schematic capture window is automatically opened. The PIC is automatically placed in the window. You can then connect the other circuitry that needs to be connected to the PIC. In our case, we want to produce the flasher circuit. For simplicity, we've connected one diode to each of the 5 ports as shown. To get the program into the PIC, or in other words, to simulate downloading of the program into the PIC, you right-click on the PIC and select Edit Properties. A window is going to be displayed. You can enter the information as per desire in the various fields. The field of importance is the program file field. This is the field that defines the program file that we need to get into the PIC. You need to browse to the folder that contains the flasher program, that is the micro C flasher project. When you get to that folder, you select the hex file that would have been produced from compiling the micro C program. In the processor clock frequency field, you enter the frequency of the PIC. In the program configuration word field, you need to enter the configuration word. That word has got to be the same as the one that is in the corresponding micro C project. So you will need to go into the micro C development environment and retrieve that word so as to make sure that these words are the same. To get the configuration word from the micro C development environment, you go to the project menu and select Edit Project. A window is going to be displayed. I'm sure you can see where to get the configuration word, where it's written configuration registers. So you take note or copy that value. So in this case, the value is 0x3b7a. You copy that value and write it into the properties field of the PIC in the Proteus simulation environment. After you've loaded the program into the PIC, you can run the Proteus simulation. To run the simulation, you click on the Run button. The Run button is the blue play button at the bottom of the window. You can also see the other buttons that are used to control the simulation process. There is the pause button and there's also the stop button. The video clip shows a simulation of the flasher. You can see the LEDs flashing. If the simulation fails to work as expected, the first thing that we need to do is to check that the program file is the one that you initially entered in the properties of the PIC. Sometimes the program file changes to another file, and once this happens, the PIC will fail to run properly. So just ensure that the program file is still the same as the one that you initially loaded into the PIC. If all is well there, you can you proceed to check the circuit, ensure that all the connections are correct and sound. If everything is okay, then you go into the micro C program. Make sure that the program statements are written in such a way that they produce the kind of functionality that you expect to get out of the PIC.